Hello, ladies and gentlemen. I hope you are all feeling fantastic and ready to look at question 24 on our 2019 Grade 11 contest. What have we got here? Consider the quadratic equation x squared minus r plus 7x plus r plus 87 equals 0. Okay, quadratic, we just don't know what r is, but we are told r is a real number. The equation has two distinct real solutions. Okay, that actually will tell me a little bit about r, which are both negative exactly when when r is between p and q for some p and q. The value of p squared plus q squared is. Okay, so there's sort of two important things they're telling me: two distinct real solutions and both negative. You can approach whichever one you want first. I think will be fine. You will need to consider both. So if I have a quadratic and I've got two negative numbers for my roots, and we do have a leading coefficient of 1 here, so that's why I can do x minus a. So imagine, I guess if I want a to be. Now, let's say a and b are my roots, and they're negative numbers. So we'll keep in mind a and b are negative. If I were to actually expand this out and compare it to my r plus 7, r plus 87, I think it was. Okay. So there we go. If a and b are sort of negative numbers, you're going to have their product here is going to be the r plus 87, but the product of two negative numbers is positive. And that sort of affects what r can be. And then you'll have the sum of these two negatives, and you'll have negative of that sum. So this r plus 7, is it minus r plus 7? Okay, it's minus r plus 7. So r plus 7 is the sum of these negative numbers. R plus 7 needs to be negative. Right? Because I know a and b are negative. Sum of two negative numbers is negative. I know a and b are negative. The product of two negative numbers is positive. And so then I just compare the coefficients in my expression here. And the stuff that doesn't have x, the stuff that's a coefficient of x, and then the x squared. Right? So this gives me some very nice information. So for example, we can see that r has to be greater than negative 87, and over here, r has to be less than negative 7. Now, if you just observed this, you would probably say, oh, well, that gives me p and q quite quickly. And I'm willing to bet, without grabbing my calculator and verifying, that one of these possibilities is 7 squared plus 87 squared. Right? That's what they're asking us for. But that just tells me about negative solutions. That doesn't tell me anything about distinct real solutions. I mean, heck, there might be an r value here where the a and the b are the same. So just saying, oh, we've got to have this expression be negative and this expression be positive is not enough. Okay? So we should probably take a look at what does it take to make a quadratic expression have two distinct real roots. Right, so you might remember the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. And at some point when you learned quadratics, you learned about this part in here called the discriminant. And he allows you to discover, computing that and taking a look at that, allows you to know whether or not you're going to have two complex roots with complex numbers, the same root twice. That is, your quadratic secretly looks like this, or whether or not you've got two distinct real roots. And you get two different real roots if the number in here is positive. That's exactly what you've got to have. Okay? Now for our quadratic, the c term is r plus 87, the a term is 1, and the b term is negative r plus 7, but that's not going to matter because we're about to square it. So 4 times 1 times r plus 87. And this expression is going to be quadratic in r, and it's got to be positive. Okay, so what can we have? Well, let's expand this out. 14r plus 47 minus 4r minus 348, I think. It's 4 times 87, 348. Good for me. Good for me with my mental math. But we can clean this up. R squared plus 10r, and then 49 minus 348 is negative 299. Oh, I don't exactly like that number. Can I think of factors of 299 that differ by 10? Actually, I don't. Is 299 prime? Let's see. Its square root would be about 17. Just under 18. Just above 17, just above 18. So divided by 7, no factor. 7, 11, no. 13, yeah. 13 and 27, and 13 and 23. So that works out really nicely. And actually, one of these should be positive, this one here. Okay. So we get the product of these two factors is positive only if they're both negative or they're both positive. So in order to make the discriminant positive, either r minus 13 and r plus 23 are both positive, which means r is greater than 13 and r is greater than negative 23. So we just need r is greater than 13. Or both factors are negative. Product of two negatives is still positive. And for that, you'll just need r is less than negative 23. Okay? So we get two distinct roots, if r is greater than 13 or r is less than negative 23. This is the information we know. And from our earlier work, we know to have two negative roots, the conclusion is, well, you're going to have to end up, you're sort of forced to have a value of r that's between negative 87 and, what was it, negative 7, I think it was? Yeah. Okay. But we don't just want one of these, we want both of these to apply. So you have to ask yourself, okay, my r has to be in here. Can I still have r be greater than 13? No, that's impossible. But there are some r's in this range that also satisfy r being less than negative 23. So what we're going to do is we're just going to combine these two inequalities. So some of the r's, like r being negative 8, won't work. Okay? And if we wanted to, we could double check that. So we'll have r plus 7, so that'd be negative of negative 1, so we'll have x squared plus x. And then r plus 87, you'll have plus 79 equals 0, right? And so can I actually solve this for two real roots? Well, let's look at the discriminant. B squared minus 4ac. That's certainly not going to work. That'll be negative. You'll have a problem. Okay? So that's why we can throw out some of the r's that are closer to minus 7, because we still need this condition to ensure there are two roots. You need this condition to ensure that you've got negative roots when you do have real roots. And since those are the only things they told us, two distinct real roots, both of them are negative, we know we're not searching for anything more. Any of the values in r in this range will work. So this is p, this is q, and we just want p squared plus q squared. So we grab our calculator. 87 squared, I mean technically minus 87 squared, but no one cares. Plus 23 squared, and we're looking at 8,098. And, oh, there it is. For some reason I had an arrow pointed to, oh yeah, because I said one of these answers will probably be 87. Actually, is one of these answers, well, I've got my calculator out. 87 squared plus 7 squared. Yeah, actually, it's the first answer, so So you don't want to fall into that trap. You do need to explore both the distinct real solutions and the negative solutions, and you will get an answer of E. All right. So there we go. Question 24. We have just one more question to go. Question number 25. If you haven't taken a look at it, maybe take a look at it before joining me as we finish off our Fermat paper in the next video. Until then, take care and have yourself a wonderful day.